Hey guys, so I figured I would do all of the problems in lesson 6. Some of them we did in class already, but this way you have something you can refer back to. So we're graphing piecewise functions on the Do Now page. And remember, we graph just using the knowledge that we have of linear equations. We start on the y-axis at 1. Its slope is -2. It only exists for all x's less than 2. So if I put down my domain card, right there I'm showing all x's less than 2, so I'll connect. It says less than or equal to, so this is definitely a closed circle, and I erase these other points. The next one says that the y-intercept is -4. Its slope is 5. It exists for all x's greater than 2. I use my domain card. X is greater than 2 right here. It says greater than, not greater than or equal to, so I'm going to make sure this looks open and erase the other points. And there we go, done, piecewise function. F of -4 is at 8. F of 8 is way too high up for me to see, so I'm going to substitute it in. It's definitely in this piece, which is the second piece. So 5 times 8 minus 4, 40 minus 8 is 36. And f of 2, remember an open circle means a point doesn't exist right there, so it's at -3. Then it asks for the domain of the function. So use your domain cards again. The domain of the function. This one's going off to -infinity. I can't put my card down. This one's going off to +infinity. Can't put my card down. So there you go. The domain is from -infinity to +infinity. The range, I can't put it up anywhere. It's going off to +infinity, but it does start right there at -3. It hits every single y value that's above -3. So I could say from -3 to infinity. If you like inequality notation, you can write all y's greater than or equal to -3. Either way is acceptable. You didn't have to do number 2 in class, but I'm going to do it now. So we start at -1 on the y-axis. The slope is -1, so remember it's a down 1, right 1. I use my domain cards. It exists for all x's less than or equal to 0. It did say less than or equal to, so that's definitely closed. And get rid of these other points. Second piece, -1. Slope is +2. I can put these other points. I know they're going to get erased. Remember what we had said, that in order to be a function, an input can't have more than one output. Therefore, these 2 points can't be one above each other. So these are definitely going to get erased. I know I'm going to be connecting the points over to the right. I have to connect from 0 to 5. From 0 to 5. open circle at 0. If I put an open circle on top of a closed circle, still looks closed, and it is. And at 5, it's a closed circle. And then horizontal line of 3. It's going to be someplace over here. It's for all x's greater than 5. So arrow at the end, open circle, because it doesn't equal the 5 there, which is good because it equaled 5 up there. So there we go. We can answer the questions. F of negative 2 is at 1. F of 0 is at negative 1. F of 5, it's not the open circle, it's this closed circle, so it's 9. Domain of the function goes off to positive infinity. It starts at negative infinity. It touches every x in between. It is from negative infinity to positive infinity. The range, the lowest point is here. It hits all of these y values. It stops here, but then it keeps on going over there. So really it goes up to positive infinity. From negative 1 to positive infinity. Remember, it's a bracket when it's a closed circle. We did number 3 in class. We called it a step function. We said that these actually are not so bad because graphing horizontal lines is pretty quick and easy. I need a horizontal line at 1, a horizontal line at 3, and a horizontal line at 5. But the horizontal line at 1 starts when x is negative 2 and ends when x is 0. So if we were to use our domain cards, it goes from negative 2 to 0, that horizontal line of 1. It's a closed circle at negative 2. It's an open circle at 0. Next horizontal line goes from 0 to 2. It's a closed circle at 0, and it's an open circle at 2. Next horizontal line goes from 2 to 4. It's a closed circle at 2 and an open circle at 4. There you go. It is a piecewise function, but it's given a special name called a step function. First piece, horizontal line at negative 2, but it starts when x is 2. And it's a closed circle and ends when x is 3, which is an open circle. Next horizontal line at negative 1 starts when x is 3 and is a closed circle and ends when at 4 and it's an open circle. And horizontal line at 0, closed circle at 4, open circle at 5. Last one, horizontal line at 3, horizontal line at negative 1, horizontal line at 0, horizontal line at 1. They exist in different places. So the horizontal line at negative 3 starts when x is 2 and ends when x is 0. Next horizontal line starts when x equals 0 and goes to 2, open circle. Next horizontal line at 0 starts when x is 2, an open circle at 4. Finally, horizontal line starts at 4, goes to 6, which is off my graph right there. So there we go. That's graphing piecewise functions. Now we have to do the reverse. We have to write the piecewise function according to the graph that we see. I'll call this my first piece. I first look at the slope. It's up 1 over 1. We use a squiggly bracket to list all of our different pieces. So the slope is 1 with an x, and I add on the y-intercept, but do you see it's crossing the y-axis at 0? So that's the first piece. It exists for all x's less than 0. I'm actually going to make this a closed circle here and say less than or equal to 0. At this next piece, I'll say it doesn't equal there, because remember, you can't have two closed circles on top of each other. You can have a closed circle on top of an open circle, or an open circle on top of a closed circle. This next one, the slope is 2. The y-intercept is still 0, and it exists, and in between this, it exists right there between 0 and 2. From 0 to 2. X, it exists for all x's between 0 and 2. You always put less than signs because 0 is less than 2. And then you decide if it's also equal to. I can't make it equal to 0 because it's equal to in the first piece. And the second piece, it is a closed circle, so it does have to equal there. The domain of the function, it goes off to negative infinity, and it comes up to 2. The range of the function goes off to negative infinity and up to 4. Number 8. I'll do this as my first piece. The slope is 1. The y-intercept is negative 1. It exists for all x's less than 0, not equal to, because that's open. It exists for all x's less than 0. The next piece is a horizontal line at negative 3. It exists for all x's greater than or equal to 2. So remember, when it's a closed-in circle, it's also equal to. When there's an arrow, it's going forever in some direction. The domain of the function. I can't put my function card at the end here. It's going to negative infinity. But we have something we have to talk about with the domain in this piece. I can't say it's from negative infinity to positive infinity, because do you agree that there's like this gap in between, right? There isn't anything that exists on these x's. Like there isn't any domain of 1. There isn't any domain of like the numbers between 0 and 1, or the numbers between 1 and 2. So we actually have to use this union symbol when we're doing the domain. I have to do the domain of the first piece unioned with the domain of the second piece. So the first piece definitely goes to negative infinity and to 0. The 0 is not included. The second piece does go to positive infinity, and it's starting at 2, and that 2 is included. So when you have like a gap between your pieces, you have to unionize your domain. Our range, the highest it goes to is negative 1, and it goes forever down. Now some people think that there's a gap here, but there's not. Do you see how there is a y value at negative 1, at least an open circle, and there's still y values here because the line is drawn, and there's still y values. It just so happens that there's a few y values right here, and then there's still y values, and it's going forever to negative infinity. So there's no gap between the y's. The y's start at -1 and go forever to negative infinity. A lot of people say, oh, we should write this from least to greatest, so I'll change it actually from negative infinity to -1. Number 9. The slope of this piece is 1. The y-intercept, when you don't see it, you have to continue the line. It's going up 1 over 1. You have to continue it and put in those points that were originally erased, like how we did the do now. And it's hitting the y-axis at 1. So that's the equation of this first piece. It's just that this wound up getting erased. The erasing is what tells you to write next, right? We have to say where that piece exists. The piece exists from where x is -1 to negative infinity, right? It's going forever in this direction. So it's for all x's less than or equal to -1. And I notice there's a gap here. So I'm just remembering that from when I have to do the domain. And this next piece, it also has a slope of 1. And if I drew in the points that got erased, it's going to hit the y-axis at 0. Since I erased it, I have to talk about where it exists. It's going off to positive infinity, and it's starting at 1. So for all x's greater than or equal to 1. If I talked about the domain of the function, I just made a comment that there's definitely a gap there, right? This piece goes off to negative infinity. This piece goes off to positive infinity. But is there any part of the graph in between here? There's not. So we have to unionize our domain. We do the first piece, negative infinity to -1. We do the second piece from 1 to positive infinity. I just noticed that this is a closed-in circle here. I need a bracket. And that's the domain. The range also has a gap in it. I can't put the card at the bottom. It's definitely going to negative infinity. And if I move this card up, it's touching the graph, touching the graph, touching the graph. But when I get to here, it's not touching the graph at all. So it doesn't exist right around there. And then it picks up again. So there's this little gap here in my range. So I have to unionize my range also. I have to do the range of the first piece unioned with the range of the second piece. So the first piece is from negative infinity to 0. And the 0 is included. The second piece is from 1 to infinity. And the 1 is included. So it's these gaps that sometimes get a little tricky. We did number 10 together. We had said that this has a slope of +3. And if we put in the points that got erased, we would see that it hits up here at 10. So we can say that the first piece has a slope of 3 and a y-intercept of 10. these do get erased, therefore we have to write where it exists. It exists for all x's less than or equal to -2. This middle piece is a horizontal line at 4, and it exists from -2 to +2. When you use the cards, it's easy to see where it's crossing the axis, where the card is hitting the axis, from -2 to 2. Now, remember we say x is between -2 and 2, and -2 is less than 2, so these are less than signs, but do I put any equal to signs also? It's already equal to this -2, so it can't equal here, so I'll leave that open. This is definitely closed in, so remember you have a choice. I can make it equal to in this horizontal piece, so I'm allowed to put equal to here. And then when I do this last piece, it will have to not be equal to. If I didn't make it equal to in this horizontal piece, then in the last piece I would have made it equal to. I wouldn't say that one way is any better than the other. It's just a decision you have to make, and it just can't be equal to in both places. It has to be equal to in some place because there's definitely a point there. The last piece, this line is going downward to the right, so it has a negative slope. Its slope is a -3. And if I put in the points that were erased, it also has a y-intercept of 10. It exists for all x's greater than 2. I can't say equal to since I already made it equal to in that second piece. There aren't any gaps in this domain. I would say that the domain goes from -infinity to +infinity. The range, there aren't any gaps in the range. I can't put the card at the bottom. It's going off to -infinity. And the card at the top crosses right there at 4. So the range is from -infinity to 4. And the 4 is included. It's definitely closed in there. And then just one more problem. This is going to be pretty easy because they're all horizontal. I have a horizontal line at 1. I have a horizontal line at 3. I have a horizontal line at 5. They just exist in different places. The horizontal line when y equals 1 you can see goes from 0 to 2. The 0 is included. And the 2 is not. The horizontal line at 3, you could see goes from 2 to 4. The 2 is included. The 4 is not. The horizontal line at 5 goes from 4 to 6. It's included at 4. It's not included at 6. And there we go. Finally, there's lots of gaps here, so we have to be careful. The domain are the x values. There's actually no gaps in the domain. Take a look. I could put my card here. And then if I drag this card across, it's touching the graph, it's touching the graph, and it's still touching the graph because when it leaves this first piece, it picks up on the second piece. And the card is still touching the graph, and it's still touching the graph. So there's no gaps in my domain. The domain starts at 0, and it goes to 6. The 0 is included, but the 6 is not. From 0 to 6. The domain is from 0 to 6. The range is where we have tons of gaps, because when I use my range card, it's not hitting the graph until I put it right there. It's hitting at 1. And then it's not hitting again until I put it here, which means it's hitting at 3. And then it's not hitting again until I go to here, which means it's hitting at 5. And then it's not hitting again. Do you agree that it hits at 1, it hits at 3, and it hits at 5, and that's it? It's only 3 places it hits. So this range, I have to use like my set notation and say that 1 is part of the range, and 3 is part of the range, and 5 is part of the range. There is no interval in the range. It doesn't like gradually increase like how this one was. It's just right there, and then it's just right there, and then it's just right there. So the only time we write things in like this interval notation is when we can use our card and say it's hitting the graph, it's hitting the graph, it's hitting the graph. So it's including all of these numbers until I get right there. So that's how come sometimes you can do it as an interval, but sometimes it will just be individual numbers. So that was just some practice problems. You know that your homework is to do these 3 questions. We'll go over it when I see you in class. So hope it was helpful, and I'll see you soon.